Assalamualaikum warahmatullahi wabarakatuh. I am Jibril A. Abdul Rahman, BSc 2A, and the reporter of equations defining the rotation of a rigid body about a fixed axis. First, we will go for some basics and equation that we will need to solve these problems. Let's start off with angular position. Angular position represented as a theta symbol. Now let's talk about with angular velocity. Angular velocity is a derivative of angular position with respect to time. In other words, it a change an angle over time. We show the angular velocity using a Greek letter omega. And now for angular acceleration. Thus the derivative of angular velocity with respect to time. We show angular acceleration using the Greek letter alpha. Lastly, we have one more equation which is this. It will relate the angular acceleration with angular velocity if time is eliminated. If we have question with constant angular acceleration, we can use this equation. Yeah, that's right. Now for motion of a rigid body rotating around a fixed axis is often specified by the type of angular acceleration. So we notice that the equation there is angular velocity and angular position, angular acceleration rather. Uniform rotation or angular acceleration is equals to 0. And uniform accelerated rotation or angular acceleration is equals to constant. So now we have the sample problem. Cable C has a constant acceleration of 225 mm per second squared and an initial velocity of 300 mm per second, both directed to the right. So, determine A, the number of revolution of pulley in 2 seconds. Then letter B, the velocity and change in position of the load B after 2 seconds. And C, the acceleration of the pinpoint D on the rim of the inner pulley at T is equals to 0. So the strategy of this, due to the action of the cable, the tangential velocity and acceleration of D are equal to the velocity and acceleration of C. Calculate the initial angular velocity and acceleration. So, modeling analysis, the tangential velocity and acceleration of D are equal to the velocity and acceleration of C. Since the tangential velocity and acceleration of D are equal to the velocity and acceleration of C, so our tangential velocity D is equals to 300 mm per second, and our tangential acceleration of D is 225 mm per second squared. So we're going to use this equation to get our angular velocity. So our angular velocity is equals to velocity of D all over R. So our R is 75 mm. So 300 mm per second divided by 75 mm is equals to 4 rads per second. So our to get our angular velocity, our angular acceleration is acceleration of D all over R. So is equals to 225 millimeter per second squared divided by 75 millimeter per 75 millimeter is equals to 3 rad per second squared. So now we're going to apply the relation of uniformly accelerated rotation to determine the velocity and angular position of the pulley after 2 seconds. So after we substitute, so our angular velocity, is equals to angular plus angular acceleration times time. So we are going to substitute it, and the answer is 14 rad. So 14 rad, we knew, if we remember that 1 rev is equals to 2 pi rad. So now we're going to convert it to rev. So 14 rad times 1 rev all over 2 pi rad. So the answer is n is equals to 2.23 rev. So this is the velocity v is equals to velocity of b is equals to r times angular velocity. So 125 millimeter per second, 125 millimeter times 10 rad per second. The answer is 1250 millimeter per second. And delta y of b is equals to r times theta, or angular position, is equals to 125 millimeter times 14 rad is equals to 1750 millimeter. So if we convert it to meter, so the answer is 1.25 meter per second, and the delta y of b is equals to 1.75 meter. So now we're going to evaluate the initial tangential and normal acceleration components of D. So since our tangential acceleration of D is equal to our acceleration of C, so the answer is 225 millimeter per second squared. So to get the acceleration of D n, also the formula is r of d times angular acceleration raised to 2. So 75 millimeter times 4 rad per second squared, 4 rad per second raised to the power of 2. So the answer is 1200 millimeter per second squared. So we have the acceleration of D n. So now, magnitude and direction of the total acceleration. So only we have to do is to substitute it, and the answer is 1221 millimeter per second squared. And if we convert it to meter, so the answer is a acceleration of D is equals to 221 meter per second squared. So we're going to use the tangent formula. So the tangent formula is the opposite divided by adjacent. So now, so the answer is 1200 divided by 225. The answer is 79.4 degrees. Reflect and think. A double A pulley acts similarly to a system of gears. For every 75 millimeter, that point C moves to the right. Point B moves to 125 millimeter upward. This is also similarly to the rear tire of your bicycle. As you apply tension to the chain, the rear sprocket rotates a small amount, causing the rear wheel to rotate through a much larger angle. So that's all, and thank you.